In this video, I'll show you how to solve the ALEKS problem called predicting the arrangement of electron groups around the central atom of a molecule. So to solve this problem, the first thing that we're going to need to do is draw a Lewis structure for the molecule. I have PCl4-. And to draw the Lewis structure, the very first step is to count up the number of valence electrons that are in all of the atoms in the molecule. So I have a phosphorus atom, which is in the 5th column. That's got 5 valence electrons. I have 4 chlorine atoms, and each chlorine atom has 7 valence electrons. And then also I have a -1 charge, which is 1 electron. So 5 plus 28 plus 1, this is a total of 34 electrons. Then what I want to do is arrange all of the atoms. I'm going to put the phosphorus in the center. The first atom in the formula is the center, and we're going to put the chlorine atoms around the phosphorus atoms, initially connecting everything by a single bond. Count up how many electrons that took. Those 4 bonds used 8 electrons, which leaves us with 26 more electrons to go. That's 2, 4, 6, 8 electrons. We're going to then satisfy the octet rule for all of the outer atoms. Each chlorine atom currently has 2 electrons in that bond, which means it wants 6 more. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And that leaves us with 2 more electrons to go, and those last 2 electrons are going to go on the central atom. Now we want to double check and make sure that this is a valid resonance structure. All of our chlorine atoms have 8 electrons, so they all have an octet. Our phosphorus atom has 10 electrons, which is a little extra, but phosphorus is in the 3rd row on the periodic table, and anything 3rd row and down is capable of having a lot of extra electrons around it. If we're nervous about that, we can go ahead and calculate the formal charge for the phosphorus. Formal charge is the number of valence electrons, which is 5, minus the number of bonds, which is 4, minus the number of non-bonding electrons, which is 2. That's a formal charge of -1, and that's okay. Zeros, -1s, and +1s are all perfectly fine formal charges. So this is a good structure. So now that we have our Lewis structure drawn, we need to figure out how many electron groups are around the central phosphorus atom. Electron group is referring to a lone pair or a bond, whether it's a single bond, a double bond, a triple bond, it doesn't matter. So for our phosphorus, we have 1, 2, 3, 4, 5 groups of electrons. When we're counting groups of electrons, we're not counting how many atoms. So it's not asking us how many electron pairs we have around the central atom. That's not what it's asking. It's just groups, or sometimes I refer to this as locations. How many places do we have electrons located around the central atom? We've got a bond, we have another bond, another bond, another bond, and a lone pair. So that's 5. And then the next question is going to ask, what phrase best describes the arrangement of electrons around the central atom? That's completely based on the number of electron groups. If we have 5 areas of electrons around the central atom, we are going to call this trigonal bipyramidal. And just to kind of give you a little bit of resource, if there are 2 areas of electrons around the central atom, it is a linear. If there are 3 areas of electrons around the central atom, it is going to be trigonal planar. If there are 4 areas of electrons, it's tetrahedral. And then 6, which is our other option, is going to be octahedral.